The following video will familiarize you with the Eze-Sleever machine and its operation. We will take you through the entire process of machining an end bell step by step. In order to operate the Eze-Sleever, the operator must understand how the machine electronically centers and clamps an end bell. The Eze-Sleever uses the end bell's register to align the bearing bore to the machine's center line. Most any end bell can be centered by using either the inside or the outside diameter of its register. The machine then clamps the face on the end bell's register perpendicular to the spindle axis on 6 hardened and ground clamping pads. Inside or outside centering is achieved by using 3 highly precision linear drives that are electronically synchronized. These drives are known as the centering drives. The drive at the front right of the machine is known as the master drive. The other 2 drives are known as the slave drives. After homing the machine upon startup, the slave drives are electronically synchronized with all movements of the master drive. During the centering process, an electronic encoder monitors the master's movements. Using this encoder, the slave drives read and mimic every movement that the master drive makes. The drives are coupled to precision linear actuators that are fitted with hardened centering pins. These pins drive the end bell to the machine center, similar to the jaws on a scroll chuck. While automatic centering, all 3 centering pins come into contact with the end bell. It is at this moment stall detection is made by the master drive and the drives immediately stop. This centering process is highly accurate and repeatable. The Eze-Sleever uses this process to center an end bell in conjunction with the master drive's ability to accurately detect stalls. The controls of the Eze-Sleever are simple and easy to use. All motion of the machine's table and spindle are controlled by the 2-hand anti-tied down finger buttons on the front of the machine. To the left of the operator's panel are 3 selector switches. These selector switches allow the operator to select different functions for the finger buttons to control. Both the table and the spindle selector switch have 3 settings. If both of these switches are in the bore position, the finger buttons will operate the spindle rotation. Spindle RPM is variable and can be adjusted by the speed dial located in the center of the operator panel above the E-stop. To raise or lower the table, set the table selector switch in either the up or down position. The spindle selector switch must remain in the bore position. Actuate the finger buttons to now raise or lower the table. To raise or lower the spindle, set the spindle selector switch in either the up or down position. The table selector switch must be set and remain in the bore position. Actuate the finger buttons to now raise or lower the spindle. Both the spindle and the table have 2 speeds for linear movement. The speed selector switch can also be set to slow or fast. Now that you have a basic understanding of how the Eze-Sleever functions, let's put it to work. Check to make sure the E-stop is not depressed. If so, pull to reset. Turn the power selector switch to the on position and press the home push button. The home light will flash while 3 centering drives home to each of their own limit switches. When all 3 have completed their homing function, the home light will stop flashing and remain on. Homing is a fully automatic function and must always be done prior to any setup. With the machine's table at its lowest position, pull out the loading table. Load the end bell on the machine's upper table. This can be done manually or through the use of an overhead crane. It is recommended that you use standard 3-point contact and support the end bell as close to the register diameter as possible. When loading, ensure that the end bell is roughly centered on the machine's table. Before loading the end bell into the machine, measure and record the end bell's register diameter. This measurement only needs to be within 1/8 of an inch, but will be needed later on in the setup. Load the end bell into the machine by pushing in the lower table. Be careful not to push the table into the end of stroke, but only until the table is correctly aligned with the while limit indicator. The indicator is located on the right-hand side of the lower table. Ensure that the upper table is also aligned with the X limit indicator. This is located on the right front-hand side of the upper table. At this point, it is important to have determined what type of centering is required. For this example, we will be centering on the inside diameter of the end bell, so we will need to set the centering switch to the out position. If the spindle is not at its highest position, we will need to raise the spindle before setting up the end bell. Set the speed switch to the fast position. Then, set the spindle selector switch to the up position and the table selector switch to the bore position. Now, activate the finger buttons to raise the spindle. The spindle will stop automatically at the top of the stroke when it reaches the limit switch. Since we are centering on the inside diameter of the end bell's register, we will need to set the centering axis to their minimum or smallest diameter. This way, it will be inside the end bell when we pre-clamp it in the machine. This must be done prior to pre-clamping the end bell. If we were centering on the outside of the register, the centering drives could be left in their home position. Quickly toggle and release the center jog switch in the in direction. This will cause the centering drives to travel inwards towards the spindle. When they have reached the spindle, they will stop automatically. Once they have stopped, it is okay to commence with the pre-clamping of the end bell. Set the table selector switch to the up position. Set the spindle selector switch to the bore position. Activate the finger buttons to raise the table. Stop the table when the end bell is about